Hello friends, so in the series of IOQM lectures on geometry, now we have gone through most of the basic questions of geometry and notions of geometry, followed by solution of triangle. So we have been taking up solution of triangle. Prior to SO2, we introduced you to a bit of trigonometry. So in this lecture today, we will see how cosine law is applied to various situations, how projection formula is applied, and then we will move on to other things. So, starting with solution of triangles, and in the previous class primarily solving would involve sine law and cosine law. We have gone through them. A bit of projection formula has also been told to you. Okay. Now, in cosine law, one of the questions that we did earlier, probably somewhere in geometry while dealing with right angle triangles, we will do the same thing using now cosine law. Cosine law, I think you hopefully remember, cos A is b square plus c square minus 2bc, sorry, minus a square upon 2bc. Sine law, a by sine A and this equaled to r. So, in cosine law, I think if you remember, one of the questions that we did long back insofar as triangles were concerned was that if sides of a triangle are three consecutive natural numbers, and it is an obtuse angled triangle. Find its area, perimeter, anything, or sides. So, we say if the sides are n minus 1, n plus 1, this is the largest angle. If it is obtuse, its cosine is going to be negative. So, cos of the largest angle, say C, is this has to be less than 0. And this will now conclude the things. Wanted, you can see this is definitely positive. So, it is n square minus 4n is less than 0. N is less than 4, and you can see cannot be 1, and you can see cannot be 2. If n is 2, what you get? The sides are 1, 2, 3. They will not be able to form a triangle. And if you remember long back when we said if sides of a triangle are integers and one of its side is 1, it has to be an isosceles triangle. Okay. So, what the only thing left is n is 3. So, if n is 3, sides are 2, 3, 4. Area, I think now is a very trivial conclusion. So, I am not getting into it. So, length of sides, angles are involved. Cosine law is a very good way to deal with a situation like that. If suppose two sides and one of the angles is given, if the included angle is given, suppose you are given two sides, say A, B, okay. and you are given the included angle, then this can be determined uniquely. I think it is very easy to observe that c square you can simply write as a square plus b square minus 2 ab cos c. C can be determined uniquely. But if the angle is not included, okay, suppose the situation is like this, okay, that I give you side A, or suppose I give you say this angle B, this side C. Okay, I give you side C, angle B, and side A is given. A opposite C, C is given, angle B is given. C, okay. And I give you side B. B is also given. This is not the included angle. I think you can very easily make it out. That what I have done is drawn a horizontal line, and then at angle B I have taken length C. Now, if I am given side B, what I will do is with this as center, I will draw a circle of radius B. If radius is less than this, you won't get any triangle. If the side B is less than C sin B, okay. If B is less than C sin B, no such triangle is formed. Isn't it? If B is greater than C sin B, suppose you draw a circle, it is intersecting this at 2 points. Then I think you can very easily see there are two such triangles. Isn't it? This is a C1, C2. But if has to be less than C, you have two triangles. In case you come across a situation where the side B exceeds side C, so circle that you will get will intersect this like this. So in effect you are getting only one triangle. This triangle has to be ruled out. So if B is greater than C, we get one triangle. In fact, if we remember in the previous class what we did, so these things are per se not to remember, simply write cos B C square so you have to find side A, it is a quadratic in A. And solve this quadratic. Don't try to remember these facts. If D is less than 0, you can very easily see this is the case. You can find discriminant, I am not getting into it. Okay, see, by quadratic, let me, okay, tell you just once. What is D? 4C square cos square B. 4. This is what we were saying. If B is less than C, sin B, D is less than 0. If B is greater than C, sin B, this discriminant is positive. And you can see this. If C square is greater than B square, the product is positive. So you get 2 positive roots. If B is greater than C, this is negative. So you get 1 positive and 1 negative root. Side of a triangle cannot be negative. So therefore, this is the situation. You are sometimes you can see, because you are given side B and angle B. In this case, the two triangles that you are getting, you can understand B is given, angle B is given. Both the triangles in this case, both triangles have same circumradius, isn't it? B by sin B is to R. B is fixed and sin B is fixed for both the triangles. So we can very easily conclude that even when you get two triangles, they will have same circumradius, not in radius. In radius would be different, you can see. So these are called ambiguous cases in a triangle. My request, humble request is just do this process. Don't get involved into these things. Okay, that will be a bit cumbersome. This on most occasions is very helpful in the sense that you don't need to remember expression, just do it algebraically. Proceed it in the manner as was needed. Two sides and an angle was given. You proceeded by cosine law. It is very easy to interpret that this is a quadratic, whether it has positive roots, negative roots, non-real roots. Accordingly, we can conclude how many triangles are possible. Okay. Now, if somebody says, what is the area of this triangle? Getting it? Suppose I am asking you, what is the area of this triangle? Can anyone tell me? Sometimes they say, if there are two triangles ABC1, ABC2, what is the area of triangle AC1, C2? So you can see the difference of roots here. Area of A, let me draw it in a fresh page. So difference in area will be half C. A2 minus A1, difference in roots of a quadratic, root delta by A, root delta by A, and delta is, sorry, root D by A. A here is 1, so it is root D. So half C sin B, 4 into B square This is the area, difference in area. In the previous class, I wanted to take up a question where you are simply asked, don't again, I am again saying, don't remember the formula. There is no point in remembering the formula. Okay. That is a tedious ask. What is simple is that think along quadratic lines and resolve it accordingly. Now, let us take some more problems based on, say, cosine law. So, sides, angles being provided is a good enough hint for cosine law. In fact, if we don't know Stewart's theorem, then cosine law is a very good way to find length of angle bisectors or length of, say, medians. Length of median, because we are aware of Stewart's theorem, we use Stewart's theorem in determining length of medians. Else, cosine law would have been of great help. Okay. Now, let me take a good problem, I would say, of cosine law. I like this problem. It is a problem from S.L. Looney, and it is a good problem. So, I would say that the question says a circle of radius r is drawn, and on it is taken a point O. On it is taken a point O, with O as center. A circle of radius three r by 2 is drawn. On the smaller crescent shaped area, on the smaller crescent shaped area, a circle of radius r by 8 moves from one extreme to another. From one extreme to another. Always touching the circle of radius r internally. Find the length of arc covered by center of this smaller circle as it moves from one extreme to another. This is a very good 5-mark question. Okay. We have done some simpler problems earlier. This is a good problem in that sense. So just look at the language of the problem, think about it, advising all of you to just give it a thought, pause the video, think about the problem, comprehend it, draw an appropriate diagram, and then try to fathom how to do it. Take your time, take 5-10 minutes. If it is not possible for you to come up with a plausible solution, or you are not getting a headway, then look at how we started with solving it, then again pause it and then proceed. So take your time. These when we are preparing for examinations like this, one of the key aspects is patience. Try to concentrate, give substantial thought on the questions that appear, because not everything would be at the click of a button. Not everything would be grasped or understood, or you being able to solve it in a very short span. So I am requesting all of you to please take some time, give it a thought of your own, and then only proceed ahead. Now I am moving ahead. You can pause the video and then proceed. So you are given a circle of radius r. So let me draw a circle of radius. Suppose this is a circle of radius r. O is a point on the circumference. Now with O as center, you draw a circle of radius 3r by 2. Now in the smaller crescent, say this is the crescent of a moon. If you remember, we say crescent of a moon. Now in this region, you are moving a circle of radius r by 8, which is always touching this blue circle. Say it's and it keeps moving. Say it can keep rolling. So to what point will it roll? It will roll to a point where it starts touching the larger circle externally. This is one extreme and this is, say, another extreme. It cannot go further ahead. And it keeps on moving, touching this, touching this, touching this, and then ultimately it will stop here. So you can say this is one orientation. Now what can we conclude from this? We can conclude that because the circle is always touching this blue circle internally, let me draw it separately. This is the blue circle. This is the white circle. Center of this circle, center of this circle. Distance between the centers is r1 minus r2. So radius of this smaller circle is r by 8. So r minus r by 8. So if it moves an angle theta, it is moving in a circle of radius 7r by 8, whose center is center of the original circle. So this point is C. So our circle of radius r by 8 is moving in a circle. The center of the circle of radius r by 8 is in itself moving on a circle of radius 7r by 8, because it is always touching this blue circle. What is length of the arc? If this angle is theta, Okay, and this radius is r. What is length of this arc? R. If theta is 2 pi, you say 2 pi r is the circumference. If theta is pi, you say pi r, that is semicircle. Fine. Now look at it. In this extreme situation, let me draw this triangle. You can say if this angle is theta, on the right will also be theta. So, length of path is into 2 theta. Now, can we find this theta? If this is theta, this is going to be pi minus theta. And I think rest we can very easily see. This is r, this is 7r by 8 always. And in the extreme situations, this white circle and this yellow circle are touching each other externally. So, what will be this side? 3r by 2 plus r by 8, 13r by 8. We know all the three sides. Finding the angle, cosine law is better because if sine theta is half, we have to think in two different directions, whether the angle can be acute or obtuse. But here but in cosine law that is sorted. So, cos pi minus theta is r square plus 49 r square by 64 minus 169 r square by 64 upon 2 7r by 8. So, you can see r square gets cancelled out. 64 cos pi minus theta. Let me write it here only. 64 plus 49 minus 169 upon 2 into 7 into 8. You will get, because 64 and 8. Okay. 49 minus 169 minus 120. 120 minus 64, 56, minus 56. So, this is minus 56 upon 112 minus half. What is cos pi minus theta? Minus cos theta. So, cos theta is half. I think now we can very safely say theta is pi by 3. This is 7r by 8 into 2 theta is 2 pi by 3. This is 7 pi r by length of the path. This is the length of the path traversed by central business. I would say it's a very beautiful problem and application of cosine law was the key in dealing with this. Okay, application of cosine law was key in dealing with the problem. So, this is what I am saying, that in case geometry turns out to be a bit demanding, then trigonometry is a very good way to proceed. So, we have taken some questions of sine law, some questions of cosine law, Now we'll move ahead and deal with other formulae. Length of median, I think we had already found using Stewart's theorem. So I hope you remember it. That can be of use here also. Cosine law, if you want to do one more problem, another beautiful problem I saw some days ago was ABC is an equilateral triangle. ABC is an equilateral triangle. P is a point inside the triangle. If PA is 3, PB is 4, PC is 5, find side. In fact, all the sides are equal. Now take an equilateral triangle. Okay, PA is 3. PA is 3, PB is 4 and PC is 5. 3, 4, 5. 3, 4, 5 for a lot of reasons turns out to be a right angle triangle, and therefore a lot of our thinking goes into determining whether an angle be 90°, but these are not sides of a triangle per se. That is an issue. So, because if we randomly start taking angle theta alpha, that would be too much. Okay. So, how do we get to it? This is 3, this is 4. If we are able to somehow draw triangle 3, 4, 5, we generally feel very happy about it because you get a perfect right angle triangle. The purpose is to find side of this triangle. So, if you look at it very carefully, this distance is 5. Now, just look at it. It's a fantastic idea that if this is rotated by an angle 60°, this is AC, I rotated by an angle 60° about A. C will come to point B, B will get rotated by 60°. You will get an equilateral triangle. Okay, so this is in fact, okay, so this is point P. C comes here, P also gets rotated. This is going to be always 3. Okay, so okay, this say P comes here. This is going to be 3, isn't it? This is going to be 60°. We have rotated this by about A by 60°. This is 60°. And as needed, P reaches here, so PB. So this is say this becomes 5, this becomes 4. See, this gets rotated by 60 degree. Okay? And what happens? This distance 5 is now here. This distance 4 is here. So, this is the situation. This is 3, this is 3, this is 60 degree. So, this is also 60 degree. And this side is 3, isn't it? This is 3, this is 4, this is 5. So, what is this angle? 90 degree. So, you can think of triangle PAB. Now, think of triangle PAB simply. You are given two sides. Three, 4, and what is this angle? 150 degrees. You can find side AB, cosine law, two sides and the included angle. So, cos, so AB whole square is 3 square (25) plus 12 root. The side of the triangle is root of 25 plus. Another beautiful problem, the crux was rotation, not cosine law. Cosine law was a very trivial conclusion of what we were thinking about, what we had to do. But if you see, it is also a very beautiful problem. I will rate it as a 5-mark problem, because this thought that because it is an equilateral triangle, because if you rotate by 60 degree, the distances would be such that you will get a right angle triangle. The aim was, can we do something to get a triangle like this? And incidentally, it turned out that if we rotate about A by 60 degree, it could have been any other also. So, but then that would have made some other angle 90 degree, but that is fine. The primary idea was rotating it, and once you get into it, you can see that it is a beautiful problem that we have been able to solve. So, I would recommend all of you that the previous two problems, they were good problems. Okay. Even if you were not sure and you, instead of solving it on your own, you went ahead and saw the whole video, I am again suggesting that, say, after this lecture is over, read the problem and try to do it on your own. Even after seeing how the things are to be taken up and solved in the two problems, even post the class, if you are able to solve it on your own, that will be of great help. That means you have grasped the notion, and what was to be needed is something that you can fathom if once you are told. This rotation part, we will come across other questions where we will see how on occasions rotation is of help. Okay, just the thought came to my mind. I solved it, say, 5-10 days ago. Student asked me this problem, and I just remember it's really a beautiful problem. Okay. Now let us go to other formulae, half angle formulae in trigonometry in solution of triangle. Okay. So half angle formula. Okay. So what are half angle formulae? See, cos A is 2 cos square A by 2 minus 1. So what is cos A by 2? Isn't it? Fine. So cos A by 2 is, you can see, B plus C plus A. So cos A by 2, B plus C plus A by 2 is S. B plus C minus A by 2 is S minus A. You can also write this as 1 minus 2 sine square A by 2 and do the similar exercise to get sine A by 2. I am just writing it, okay. So it is, I would request all of you to do it on your own. S minus B, S minus C by BC. Similarly, for other angles you can find tan A by 2. What is tan A by 2? Just divide them. Sin A by 2 upon cos A by 2. And I think this would give you a good enough hint. SS minus A, S minus B, S minus C, Heron's formula. So this is delta by S into S minus. You will see that this is more useful. And similarly for tan B by 2, tan C by 2. Tan A by 2 is delta upon S into S minus A. Okay, so cot A by 2 is you can very easily see that cot A by 2 plus cot B by 2 plus cot C by 2. His denominator is going to be delta, delta is area of the triangle, 3s square minus, you can see s into s minus a plus s into s minus b plus s into s minus s into a plus b plus c. This is 2s, this is s square by delta. If you remember our last class, we said cot A is cos A by sin A, cos A is 2bc sin A, which was 4 delta. Some people ask you in a triangle what is sigma cot A by 2 upon sigma cot A. 4 delta is common and what you get is a plus b plus c whole square in the numerator, and in the denominator what are you going to get? Just write it thrice cyclically. So, what will it be? I think you are able to guess, okay. B square will appear twice with plus and once with minus. A square appears once with minus, 2 with plus. So, all in all, this is the result that you have. Not necessary that you remember it. Cot A by 2 is something that is useful, and I think from this you can also gather if sides of a triangle are in AP, they are equimultiples. See, A, B, C are in AP. So, minus A, minus B, minus C are in AP. If you add S to all of them, they are in AP. You multiply all of them by S, and now you divide them by delta. In sequence and progression, hopefully you would have seen it. If sides of a triangle are in AP, so are cotangents of half its angles. Side sin A, sin B, sin C will definitely be in AP. Okay, see a formula of trigonometry, how is it useful? ABC in AP. So cot A by 2, cos A, cot B by 2, cos B, cot C by 2, cos C. Because cot A by 2 and what is cos A? 1 minus 2 sin square A by 2. This is cot A by 2 minus 2. What is cot? 2 sin A by 2 cos A by 2. And we know already, even though this is a fact that we have just now known, but if you remember this, cot A by 2, cot B by 2, cot C by 2 are in AP. Sin A, sin B, sin C are in AP. Okay. So, difference of corresponding terms of an AP will also result in an AP. Suppose you have one sequence A1 plus D1, A1 and A1 plus 2D1, and there is another sequence A2. If you corresponding terms are added or subtracted, the resulting sequence will also be an AP. A1 minus A2, A1 minus A2 plus D1 minus D2, A1 minus A2 plus 2 times D1 minus D2. So, resulting sequence 2 is an AP. If sides are in AP, sin A, sin B, sin C are in AP, cot A by 2, cot B by 2, cot C by 2 are in AP, that is good enough. We must be able to quickly recall it. This is just a question that we have gone through. Okay. So, half angles tan A by 2, see, expressions involving radical signs, square root and stuff are rarely used, even though I am not saying that don't remember it. Tan cot, you would see that they would turn out to be more useful because it does not involve root, even though you can say delta, but delta is something that we have commonly dealt with. Okay. Now, let us say we discuss circumradius. Okay, so in circumradius of a triangle, what is used is delta is half BC sin A, and sin A by sin rule is A by 2r. So, delta is ABC by 4r. This you can see is an expression whose utility involves knowing almost everything of the triangle, sides ABC, and therefore, in solving problems, this is not something that we go to at the very beginning. Because more often than not, so much data will not be provided to us. We started our sine rule with this. Mostly, this is the way out to find circumference. One side and one angle. Angle and the side opposite to it. If it is known, we can very safely find circumradius. If you look at it in terms of the problem solving requirements, this much information is rarely available. A side and an opposite angle is good enough to determine the circumradius. Okay. So suppose somebody says, let me ask you a question, okay. In triangle ABC, let me think. In triangle ABC, suppose we are given that angle bisectors meet the circumcircle at P, Q, R. And we have to find ratio of area of these two triangles. Both the triangles have same circumradius, isn't it? Generally in examinations, this is given with data. Okay, I am not getting into data. What to do, that is the primary thing. So if triangle ABC is known to us, what will we do? We will say we are asked area of ABC, a known triangle, upon area of PQR whose vertices are points where angle bisectors have met the circumcircle. So what do we do? Area is half BC sin A, B is 2R sin B, upon, you will see R remains the same, so sin A, sin B, sin C, upon fine. Now just we have to find angles of this triangle. This is angle bisector, this is A by 2. Angle in same segments are equal. So if this is A by 2, this will be A by 2. This is A by 2. So this will be A by 2. Okay. This chord B by 2 subtends B by 2 here. This chord subtends B by 2 here, it will subtend B by 2. And similarly, C by 2, C by 2. Okay. So A plus B by 2. Upon sin A plus B, see A plus B by 2 is sin pi by 2 minus C by 2. So cos A by 2, cos B by 2, cos C by 2. This is 8. If you remember, what are the formula of half angles? S minus B, S minus C upon BC. Let me write it. See, somebody may only give you sides and ask this question. So, S minus B, S minus C, S minus C, S minus A, S minus A, S minus B. So, I can give you sides of a triangle as say 3, 4, 5 or something like that. What is this ratio? So, I think you can very easily solve it. Somebody may also ask you that whether this ratio is greater than or like this. If you are able to see, please solve it. This ratio is always going to be less than equal to 1. Okay, just think about it. How would you get it? Okay, instead of telling you everything at this moment only, this I will leave to you as an exercise, so that when I start the next lecture, I will tell you how you get it, and if you do it on your own, it will be fantastic. In radius remains and some other things remain insofar as the solution of and properties of triangles are concerned, that we will take up in our next class. So, hopefully we will be over with solution of triangle in our next lecture. Post that, we will take up problems where combining some aspect of geometry as we did today also. So, even in this angle in same segment are equal, some aspect of geometry, some trigonometry or pure geometry, pure trigonometry would be helpful. That will primarily be practice session. Hopefully, all the theory that we need to know in so far as IOQM is concerned would be over hopefully by next lecture. Thanks a lot.